Measurement lesson number 5, scale diagrams. This is not an overly challenging concept. You will need a ruler, and the lesson and the assignment will be quick. That means there will be time at the end of the block. I am hoping that we can correct some quizzes together so you guys can get an idea of how you're doing. Okay, what page are we on here, folks? Thank you. Okay, page 33. You will need a ruler, and let's go through this. All right, people, focus on me. Thank you. Highlight the word scale. I am guaranteeing that all of you know what that means or have some sense of what it means. For example, a map of Canada. Obviously, you cannot fit the entire region of Canada onto a piece of paper in reality. So you have to create a model. How do you create a model? You need a scale. The scale can be given to you in all 4 of these different ways. Okay, typically it's the first 3. A statement, a rate, or a ratio. The statement is very clear. 1 centimeter represents 0.5 meter. I would do this. 1 centimeter is equivalent to 0.5 meter. That's what I would do from the statement. And I would not be lazy with the units, because the units, if you write them down, it will guarantee success, I promise you. The rate, remember, is the ratio with different units. Ratio with different units. I typically don't use rates if I'm given a scale, but it's exactly, the math is very similar to the statement. Rather than say 1 centimeter is equal to 0.5 meters, you say for every 1 centimeter you're given a half a meter. So it's 1 centimeter, and then you'd use this word, 1 centimeter per 0.5 meters. Very similar. Now the ratio of 1:50, this is the one that really sometimes messes some people up. This ratio indicates that 1 unit on the diagram represents 50 units of actual length. So last day, do you guys remember we were using the terminology new versus old? Okay, so it's saying that if the new thing is 1, the old thing was 50. A better set of vocab for this would be model, original. So the model, or the new thing, always goes first. So yeah. Is this a reduction or an enlargement? Why is it a reduction? Excellent answer. The number in the first part of the ratio is smaller than the number in the second part of the ratio. So just quickly on that, like 1/2. If you multiply 1/2, will you get smaller or bigger? Smaller. If you multiply by something by 3/2, smaller or bigger? Bigger, because the number that goes first is larger. Okay? And the decimals for these would be 0.5 and 1.5. And you learned last day that if you multiply by something bigger than 1, it's enlargement. If you multiply by something less than 1, it's reduction. And remember, we always multiply by the scale factor. Okay, you always multiply. I know some people last day were dividing, and I'm like, yeah, if you understand that, sure. But as a rule of thumb, typically we always are multiplying, never dividing. Even though multiplying by 1/2 is the same as dividing by 2. Okay, and then in this section in particular, you got these line graph scales. Okay, so they want us to measure the shark at the top of the page. I measured it with my ruler. You can go ahead and do that yourself. They want you to go from the nose to the middle of the tail. So from the nose to the middle of the tail, I got something like that. So what's the distance of that line? I measured 9.5. What are you guys getting? 9.5? Okay, let's go with that. Let's go with that. Let's go with that. Now, is that 9.5? I know it's close, right? So 9.6? We're using inches? Don't use inches. Inches are tough. Let's stick to metric. That's good. A lot of people have trouble with inches. So that 9.5 centimeters, is that the model or the actual? Good, it's a model. It's not a real life shark floating around in the water. Okay? Okay. So you can jot that down. Model 9.5 centimeters. Now, what scale did they use for this picture? Great white sharks can grow to a length of approximately 6.5 meters. The diagram is a scale drawing. To determine the actual length of the shark, we need to know the scale used in the diagram. Okay. So scale factor is going to equal model divided by original. Okay? That's the scale factor. That's the scale factor, which I call SF. The scale statement, however, the scale statement is different. Now watch what I would do for the statement. I would say, remember model goes first, 9.5 centimeters, colon, what was the actual? 6.5 meters. Okay, that's the scale statement. What would the rate look like? For every 9.5 centimeters, we will get 6.5 meters. You guys okay with that so far? Take out your calculator, perform the division with the calculator, and I highly recommend you use these ones. And it goes... That's perfect. That's perfect. So 9.5 divided by 6.5. And then if you want, you can hit this. Once you hit enter, you can hit math fraction enter. And then it will give you a proper fraction. Because most of the time, fractions don't have decimals. So it would be 19 for every 13. Okay? How did I get that? I used the math button, and then I used fraction button. Okay? If you don't know how to do that, you can touch base with me later. Okay? Now, the scale factor is a whole nother problem. Because for scale factor, you need the same unit. Scale statements, you can have different units. Different units are just fine. Different units are actually perfect. For statements, it's perfect. Different units is great. But if you wanted to calculate the scale factor, you would have to have the same unit. So I would have 9.5 centimeters divided by 650 centimeters. You guys okay with that conversion? 6.5 meters. I just had to move it 2 decimal places over. 650. Beautiful. So then 9.5 divided by 650 for the scale factor is about 0.015. Does that seem reasonable? You got this massive shark, and then you're going to draw a little guy on a paper? So you're going to times by something quite small, right? Okay? I believe this section is all about scale statement. The last section we talked a lot about scale factor. So just if you're asked to calculate a scale factor, just make a little note here that you have to have the same unit. And units are troublesome. Like even NASA blew up a satellite one time because of units. So millions of dollars, like the smartest people on the planet working on this, and they blew up a satellite because of units. Okay? So if you screw up units, don't feel bad. Okay, so we will just stick to scale statement for the rest of this section. You will need a ruler. So go ahead and put your ruler on the diagram, and please get Edmonton to Calgary distance, please. Look, I know it's exciting, you guys. Please stay focused, though. Edmonton to Calgary. Go ahead and measure that straight line distance. What are you guys getting? And then we'll just take an agreement. What do you got? 4? Okay. Anybody else? 4? 4.2? It totally depends on your photocopying, because I got 3.7. It totally just depends on 4. Yeah, it's the photocopier. Like, they're not all going to come out perfectly the same. Do you guys want to just agree on 4? 3.7? That's what I got. Yeah, you might be measuring from like midpoint to midpoint, or so. Do you guys just want to agree that it's 4? So let's just agree that it's 4, just so everybody is happy. Now, of course, is that 4 centimeters the scale, or the model, or the actual? This is clearly the model. Why? Because it's a scale diagram. It's a picture of a map, right? That's a model. Now, this is the scale that the map uses. What do you think this represents? 1 centimeter. If you put your ruler on that, it should line up perfectly to 1 centimeter. Do you agree? So then from that scale, you could get the scale statement that I'm most comfortable with. 1 centimeter represents 75 kilometers. That's what I'm most comfortable doing. I don't like using rates. I prefer proportional reasoning when it comes to scale. This is what it makes sense to my brain. Now, if the scale says 1 centimeter is equivalent to 75 kilometers, then the measurement that we took of 4 centimeters, Trinity, is equivalent to kilometers. That's how I think of it. If 1 centimeter is equivalent to 75 kilometers, then 4 centimeters is equivalent to kilometers. And then this is just cross multiplication. We times these two and divide across the unknown. Most of you guys are like, this is so easy. It's just 4 times 75. But just for clarification, 4 times 75 divided by 1, and you get question mark. Just in case it wasn't 1, you know where it would go. And that's 300. I can't believe I used the calculator for that. Now that's roughly accurate. If you've ever driven to Calgary, you know it takes about 3.5 hours or so. So it's roughly accurate. Guess what? That's the entire lesson. So this one, you want me to go back? Oh, that's funny. I didn't know you had a good sense of humor like that. Now, this one, it's a picture of BC. I'm not as familiar with I mean, it was Edmonton and Calgary, so it was really easy. But this one wants me to find Hazelton and Prince George. I couldn't find them, and I just gave up. All right, can you show me where is New Hazelton? Just come point on my iPad here.
New Hazelton is right up there.
Oh, thank you. Oh, okay, and where's Prince George?
Prince George is right there.
Where?
Right there next to Prince.
Right here. Okay, thank you, dear. Are you from BC?
3 years. I was there 3 years. I was born in BC.
Beautiful. Hazelton to Prince George. Could you guys please get a measurement of that for me? And then we will have an agreement on what it is. I got one man saying 3.5 centimeters. .5. Okay, two people have said 3.5. Let's go with that. What is the scale saying? 1 centimeter for every 100 kilometer. So this one's nice. If 1.5 represents 100, then 3.5 represents... Yeah, he's got it. It's so beautifully simple. But if it's not obvious to you, please, you need to remember this math. 1 centimeter for every 100 kilometers. And I'll just make a little note on there. What is what? Again, here is your model. Here is your original. Okay, so be consistent. What did we measure 3.5? Is that a model or original? Model. So it would go on the left. Notice the units line up beautifully. Then over here we can say X kilometers. Cross multiplying, and obviously you get 350. Now the next question is about common sense. So you can go ahead and talk to your partner about that. Okay, so class example 4. Again, you're going to have to use a ruler and measure the distance from the top to the bottom. So from top to bottom, you need that measurement. Please throw some answers out. I'm hearing 8, and that's what I got. Okay. So here's 8. Okay. So I've been doing the statements, so I'll just do the statement, and then you can finish the other two. Notice I put the model first, original second, and I've included units for communication purposes. Now, go ahead and write it as a rate, and then go ahead and write it as a ratio. And just as a reminder, the ratio is like the scale factor, and you need the same units. Okay, so okay, So let's take a look at the rate. Obviously, you would just put centimeters on top and meters on the bottom. And this is perfect. If I said as a rate and you put this, I would be so happy. What if I asked for a unit rate? Could you do that? What if I asked for a unit rate? Or maybe a better word for that would be like a lowest terms. If you put this in your calculator, 8 divided by 240, and go math fraction, what do you get as a fraction? Beautiful. So for every 1 centimeter, you will travel 30 meters. Okay? So a lowest terms fraction might be asked, okay? So just keep that in mind. Lowest terms could be asked. And I just recommend the shortcut on the calculator. You just hit the math button and then enter. Okay, now the hard part is the ratio. The ratio is like the scale factor, and you need the same units. Okay? So, which one are we going to convert, centimeter or meter? Meter? Okay, so 8 centimeters to, how many centimeters is 240 meters? You'd have to move the decimal how many places? Twice. So then you'd add 2 zeros and you'd have 24,000. So as a ratio, those units will actually cancel. So hopefully this makes sense, especially those of you that are kind of working ahead. For ratios, you need the same units, and then the units cancel. So if you're given a scale with no units, that's because the units have canceled. Okay, and then now this 8 divided by 24,000, in lowest terms, 1 to 3,000. With no unit. With no unit. If you can't do that on your calculator because you don't have the fancy Texas Instruments, you have to see what those two numbers are both divisible by. They're both divisible by 8, and you get these two values. Yeah. All right, last one, and then that's it for me. So I'll let you have the whole block to finish your homework. And then at the end of the block, we will mark some quizzes. Okay, here, Kylie here. She's going to do a little design here. And look at this. What would you call this? A scale what? Scale what? Good. I like this guy. Statement. Scale statement. Okay. Because the units are the same, this is the ratio. The units will just cancel, and you get the ratio 150. You could also write it as a rate, 1 centimeter for every 50 centimeters. This would be the rate. This would be the ratio. And up above what they gave us was the statement. Now, I don't know what they even want us to do yet. I'm just brainstorming here. This is what we know. Okay. It says that the actual dimensions of the storage room is what they want to calculate. So we want to find out actual, and we've been given the model diagrams. Obviously, your storage room is not going to be 8 centimeters by 12 centimeters. That's a bit of a hint, right? As well. So you know you got to get bigger. And if you guys remember that last quiz, what could I do to 8 and 12? What could I do to make them bigger? Multiply by what? 50. Is it obvious? Okay. If it's not too obvious, let me just remind you that this L and this W represent a length by a width. That X right there, you would read that, whoops, you would read that as by. So you have to convert each one of those dimensions separately. And like I said, I prefer the statement. And then I can cross multiply. Okay? So if 1 centimeters is equal to 50 centimeters, then 8 centimeters is equal to X centimeters. And then I cross multiply. And you see that, yes, I just have to times by 50 and divide by 1. So 8 times 50 is 400. And do the 12 will be identical. You just got to times by 50. So change that 8 to a 12 and do it again. 12 times 50 and I get 600. So these are the dimensions of the actual room, not the scale, the actual. So this is actual. So that's part A. And what about part B? What are the dimensions on the plan if the dimensions of the chocolate section? Oh, it's a candy store. I love chocolate, especially chocolate with peanuts. It's like my favorite. Like chocolate almonds, oh my gosh. I could eat bags and bags of this. All right. Also, like, before we move on to part B, let's just convert this, because 400 centimeters, like, you would just say 4 meters by 6 meters. That's how I would communicate that one. Just convert those back to meters. Now, if we look at part B, this time, compared to what they did on in part A. In part A, they gave us the model. In part B, what are they giving us? We're given the actual. So if in part A you times by 50, what do you think you're going to do in part B? Divide by 50. Okay, so let's check out why. I know that 1 centimeter goes with 50 centimeters, model to actual, and I was given actual. So I got to put 3.5 right there. But I'm smart. I'm a smart individual. In the numerator, I have centimeter. So in the denominator, I also need centimeter. So that 3.5 has to go in as 350. And then I can solve for X centimeter, what it would be in the model. Now, if you follow the cross multiplication here, this time it's backwards. 1 times 350, is that going to give us anything different? But then to get X, you have to divide out 50, and then hence there's the divide. 350 divided by 50 is 7. 7 centimeters for X. Now, if you're a smart, logical person, you know you're going to do the same thing with the 475. So just replace the 350 with 475 and do it again. Notice I didn't put 4.75. It's 475. It's got to be in centimeters. And I get 9.5. Good, 9.5. So the new dimensions for the model, 7 by 9.5. This is for the model. Okay. So that's it. You can do homework. Then at the end of class, we'll mark quizzes.